Well, hello, chemistry. We're going to talk about hybridization of electrons. We're going to be using orbital diagrams, and this is going to be so exciting. I want you just to try your hardest to hold still and contain yourself. Okay, here we go. Now carbon. Carbon has got 6 electrons, okay, and it fills up the 1s2 orbital and 2s2 orbital. And then we put in the 2 last electrons in the 2p orbital. But this doesn't make sense because this shows that it's got 2 unpaired electrons, which means it should have a +2 charge. And if you look at your periodic table, it should have, well, it could have a +2 charge, but it could also have a +4 charge. It could also have a -4 charge, but the whole thing is 4 is its most common charge. And so what happens? Well, what they think happens is that they think that, oopsie, hold on. What they think happens is that instead of going there, they think that this one, it goes over in the, right here. Okay, so it's now showing that it has 4 empty spaces next to each one of these, and that it can actually hybridize and go into what they call a 2sp3 orbital. 2sp3 orbital. And so now that that's hybridized like this, that makes sense how it would have 4 spots to connect to another atom or atoms, so that they would have 4 unpaired electrons here, so it would make 4 bonds. Which carbon we know does. Through testing and just doing chemical experiments, we know that it connects to 4 different things. So this is a theory of how they think that it happens and how it hybridizes. Now the next question you're going to be asking, like, well, gee, I think, what does she want from me? Will she want me to do this on the test? Will she want me to do what we've been learning all this time on the test? What will she want from me? And the answer is that I want you to do what we've been doing this whole time, except for I will have one test question where I'll ask you like a certain element on there, and I'll ask you to show what would happen if it was hybridized, and then what would its charge be. So let's practice with one more. Okay, and this one I want you to think about the aluminum. Okay, so look at aluminum number 13 on your periodic table. And aluminum, what would its electron configuration be? Okay, it just so happens I happen to have it here, and it would fill up a 1s2 orbital, 2s2, 2p6, 3s2, and then just 3p1. Okay, well, you know that aluminum has got a +3 charge, so this can't be right. This is just a +1 charge. In fact, if you look at that little itty-bitty number right above the aluminum symbol, it's got a little itty-bitty 3 right there. That's telling you that that's the only charge it can have. So this does not make sense at all. So what happens? They think that this hybridizes. Let me get rid of that thing. Okay, they think that it hybridizes and that it goes right here instead. Okay, so what did I do? I just went and took that electron that was upside down here, and I placed it over here. Okay, now this makes sense. So this would be an sp3 orbital. Okay, and it's hybridized now so that it's spread out over the 3rd energy level, and it's as far as it can fill up. I mean, it doesn't have enough to put in here, so it can only fill up those ones, and it amazingly would have 3 unpaired electrons, which would explain why aluminum can have a +3 charge. So what do you think? Well, if you'd like to try another one, why don't you go ahead and try silicon number 14, and we'll check the answer to that when I return. So, well, you have a great day without me, and I will see you tomorrow.